Assalamu alaikum kids, this is Ayaz and I'm going to teach you math for grade 7. It's week 4 now and the lecture is 1 of week 4 and the topic is other forms of inverse proportion. You can find that topic on page 29 and it's topic number 1.6. And let's have a little recall back, because you have already studied now inverse proportion. So what is an inverse proportion? Inverse proportion basically is like direct proportion, a relationship between two or more quantities in which now if one quantity is going to increase, the other will decrease now, and or if one quantity is going to decrease, the other will now increase, and this increase or decrease is going to be in proportion. Or mathematically, you have already studied now, inverse proportion relationship can be written in the form of equation y2 over y1, x1 over x2 now. Or just take a cross multiply here and you will get x1 y1 x2 y2. So these two equations are basically equivalent. It's the same thing, just mathematically manipulated. And if we draw the inverse proportional relationship between two variables y and x, it's going to be a hyperbola. Means if you draw the graph between y and x, on one axis you take the value of y, on the other axis you take the value of x, it comes out to be a hyperbola, not a straight line. And but if you draw a graph between y and 1 over x, means if you plot the values of y on one axis, along one axis, while the values of 1 over x on the other axis, it's definitely going to be a straight line and passing through the origin. So that's a kind of recap. You have already studied that, and now we are going to go for the today's topic. And the topic is basically now other forms of direct inversely proportional relationship. Like you have remember, we did already that other forms of direct proportion. Now it's other forms of inverse proportion now. Since we already know if y is inversely proportional to x, we can write it down, y is equal to k over x. Or just take the x which is on the right side in the denominator, move it on the left side, it's going to be multiplied over there, so xy is equal to k, and k is of course constant of proportionality, and k can't be 0, but because if you put the k as 0, so everything goes as a 0. So now in other forms of inverse proportion, let's take an example that if y is inversely proportional to x square, in this case, according to the definition of inverse proportion, y is equal to k over x square. Or take this x square from the right side on the left side, it will be x square y is equal to k. Same, k is a constant of proportionality and is not going to be equal to 0. So you could see here the first relationship, y is equal to k over x, is basically kind of linear relationship, and here in the second one, that is going to be not a linear relationship. But if we plot the graph between x, between y and 1 over x square, it's definitely going to be a straight line passing through the origin. But if we draw the graph between y and x square, it's not going to be a straight line, In fact, it's going to be a curve. So graphically we could detect, we can see whether this relationship is inversely proportional or not. So that is the other forms of inversely proportional relationship, and that is not going to be a linear. See here, let's solve the practice note 12, which you can find in your book 2 on page 30. So carefully understand and look on the screen now. This practice note 12 asks us that we have to state which two variables are inversely proportional. You see, the first part is there, y is equal to 4 over x square. All the three parts here, you can see the powers are involved, and it's not the straightforward, are not the simple relationship which you have already studied in the simple inversely proportional relationship. So let's solve this practice now. The first part says y is equal to 4 over x square. So just mathematically manipulate this one and move the x square from right side to the left. It was divided on the right side and goes to the left and will be multiplied there. So you see x square y is equal to 4, and since 4 is a constant, so it means y is inversely proportional to x square. Y is not inversely proportional to x. And the second part here says y square is equal to 1 over cube root of x. You could see this is 3 is not multiplied. This is basically the x raised to power 1 over 3 cube root. So now same way, mathematically playing with it, move the denominator from the right side to the left. You will see y square multiplied by the cube root of x is equal to 1. Again, this product means multiplication of y square and the cube root of x. This is a product. Since the product is equal to 1 and 1 is a constant, so again we can say y square is inversely proportional to cube root of x. Again, y is not inversely proportional to x here. The third part is y is equal to 5 over x plus 2. Now again, mathematically we moved x plus 2 from the right side to the left, and we'll see x plus 2 multiplied by y is equal to 5, and 5 is a constant. So y is inversely proportional to x plus 2, and again I will explicitly say here y is not inversely proportional to x, rather y is inversely proportional to x plus 2. Okay, so champs, it's your turn now. So you're gonna take a short break here as usual, pause the video for a while, go to your book 2, page number 30, example number 12 there. Go through each and every step of the example. It's solved, of course, and try to understand that one, and then come back and I hope you have understood the topic. And your first assignment of week 4, you have exercise 1D in your unit number 1, and the question number 3. There are 5 parts there, A, B, C, D, E. All the 5 parts are exactly the same as practice now we did and the solved example. So please try to do that one. and I'm hoping to get back the responses and from you guys. And that's it for today for the lecture 1 of week 4. So goodbye, take care, thank you.